Hello, and a very, very warm welcome here to our online event for the HolyGrail 2.0 project. My name is Malene Møhl, and it's an honor for me to invite you here today to the city of Copenhagen. I work for the city on plastic waste and recycling. And we are very happy to be able to host the entire HolyGrail Phase 2 project here. And we really see this as an opportunity where a public and private companies can have a partnership to solve some of the obstacles that we face in the circular plastics economy. It's something that we are very ambitious and working hard on in the city of Copenhagen. Some of the things that lured us into the HolyGrail project was how we see this technology solve some of the things that we are lacking currently with the current technology. One of the things is these high quality material streams that the technology will be able to provide us with will enable this high quality recycling where the plastic that is produced from post-consumer waste can actually go into production of new consumer products. But furthermore, the technology provides us with data collection. So every time a product passes under a scanner and has this watermark technology, we will be able to track and trace the products and the material throughout the entire lifespan, and we'll be able to document where is the material going and what is who is buying, who is selling, and who is producing new raw material from the consumer's waste. So these are some of the obstacles that we see the technology can handle. We have a very exciting agenda for you today, so I'm very happy that you're joining us, even though this is online. We will take you on a tour of the test facility. It will almost feel like you're there yourself. At least we'll try to make it feel like that. But also we have some speakers here today that represents the technical team, the technology provider, the sorting, as well as the watermark technology and the project management as a whole. So without further ado, I'd like to welcome Eva Schneider from AIM, the Secretariat of the HolyGrail. So welcome, Eva.
Thank you, Marlene. And also from my side, a warm welcome to all of you to the second virtual open house of the Digital Watermarks Initiative HolyGrail 2.0, here live from Copenhagen. As AIM, the European Brands Association, driving and leading this initiative, we are delighted to be able to present to you today what has been achieved within 1 year since we have launched the project last year in September 2020. At that time, we have, of course, not expected to be able to showcase such a significant progress only achieved within 1 year. So just a quick recap on what has been done. On a technical level, our selected partners, the machine vendor Pellenc ST and the digital watermarks technology provider Digimarc, have developed the first prototype detection unit. This prototype, which combines the digital watermarks technology and near-infrared for sorting of packaging waste, achieved a higher than 95% ejection rate during the validation in September. The machine has now been shipped to Copenhagen and installed at the test facility Amager Resource Centre. And we have started our semi-industrial tests. And of course, we are now delighted to welcome you to the second virtual tour, really showcasing you the sorting and the machine. So until December, the trials and the demonstrations with around 125,000 pieces of packaging, representing up to 260 SKUs, will take place here in Copenhagen. And at the same time, there's also a second machine under development from our machine vendor partner, Tomra. So furthermore, as a second point, we also have just recently announced some big news regarding our 2 new partnerships for the initiative. So we are delighted to have the Alliance to End Plastic Waste on our side, who has joined as a key funding partner for this project. But of course also the city of Copenhagen. We have another precious partner for the semi-industrial test phase on our side. Looking at the membership of the HolyGrail 2.0 initiative, it has nearly doubled since the project's launch 1 year ago, with currently more than 130 organizations and companies from the complete packaging value chain joining forces to pioneer digital watermarks for smart packaging recycling in the EU, driving a truly circular economy. And these, all our members are actually getting together, working together in a total of 9 work packages within the initiative, contributing with their expertise, their knowledge, and looking into the technical issues around the intelligent sorting, but of course also the business cases, so the economic viability of the technology, as well as the data management system. So last but not least, all of this is complemented by our growing HolyGrail 2.0 advisory group, and that includes key stakeholders in the circular economy debate, such as WWF, the Ellen MacArthur Foundation, and the Alliance to End Plastic Waste. So during today's open house, we will go live to the machine. So we would like to have you as the audience selecting the packaging that will be tested on our sorting line. So therefore, we have now displayed a slide with the details for you to vote. So please go to menti.com or download the app and include the code 8038046. And then you are able to select your packaging. So we will then, based on the voting, we will then actually go live to the machine and organize the voting accordingly. On this note, we would now like to give the floor to Jean-Christophe Leguier, the Senior Advisor Project Development at the Alliance to End Plastic Waste, who would like to address, of course, also you as the audience. Unfortunately, he can't be with us today, but he will address you via a pre-recording. So please stay in.
A warm welcome to all participants. The Alliance to End Plastic Waste joined the HolyGrail initiative in July of this year as the main funding partner, enabling this initiative to move from a concept to real commercial applications. Created in early 2019, the Alliance conveys a global network of leaders from across the value chain, working together with partners, including agencies, governments, civil societies, and communities to effect change. As of June of this year, we have built a portfolio of over 30 projects across 60 cities around the world. Our action is guided by 4 key principles. The first one is act now. We want immediate impact, as the risk of permanent damage for future generations keeps increasing over time. We want to foster collective action, as no organization or company can tackle this one alone. We seek to have a cross-value chain approach. No single business sector can drive true system change. And last but not least, the Alliance is a do tank, not a think tank. Discussion, policies, and public pledges are good and necessary, but we need real action and real investments that demonstrate tangible results and path to viable circular economy solutions for plastics. The HolyGrail initiative combines all these key principles. The Alliance to End Plastic Waste is proud and thrilled to enable this project to become a reality. The clear objective for digital watermark technology is to become rapidly a global standard with a high adoption. I wish you a very good tour. Thank you.
And now I'm delighted to give the floor to Gian de Belder, Technical Director R&D Packaging Sustainability at Procter & Gamble, and also the chair of the HolyGrail 2.0 leadership team. He will give you an introduction and an overview of the project. Gian, the floor is yours.
Thank you very much, Eva. So indeed, it's my pleasure to introduce you to the HolyGrail 2.0 initiative. But before going there, I wanted to basically remind the people about the online poll. So we're actually going to close this poll in the next couple of minutes. So if you still want to vote, then please go to this Mentimeter and add the code 8038046, and then you still can vote on the 4 use cases. Good. So with that, indeed, I will give a very short introduction of HolyGrail 2.0. And I typically would like to start with showcasing this type of the 5-pillar model, right? So in these 5 pillars, those are the items that actually need to be true to make circular economies work at scale. So the first pillar is there, designing your packages that are fitting into a circular economy. That's really the job of the brand owners and retailers. The second pillar is then all about access to collection. Third one is consumer education. The fourth one is to innovate in the space of separation technologies. That's where HolyGrail got started. And if you have all of those 4 pillars into action, then we do have access to high quality, high quantity recycled materials for which we need to find an end market. And a good end market is to put those type of recycled resins back into packaging. So HolyGrail 2.0 actually can address 2 of the current bottlenecks. Basically the one you see here on the slide, which is the one which is addressing the consumer education, and then, as already mentioned, innovate in the space of separation. So these are the 2 bottlenecks. If we can address and solve those ones, then obviously we can increase the recycling rates. Good. So as Eva already mentioned, this is a project where indeed we are trying to make the package more intelligent by using digital watermarks, and then we use that intelligence inside the package, for example, to improve the current sorting process. The initiative obviously is nicely linked with a lot of ambitious targets. A lot of governments or member states or even companies have been pledging recently. So you see all of these items happening in the press, and we believe that HolyGrail actually can contribute and can help reaching those targets. Here again on this slide you see a couple of other targets. Again, we see it as a help really to also open up new markets. So markets such as detergent grade PCR, which today do not exist, cosmetic grade PCR. As already mentioned by Marlene, it's also a way actually to start with real life numbers, real life recycling, number generation, so data transparency is one of the deliverables as well as a way to foresee product passports for the products we are launching into the marketplace. The project actually is a continuation of HolyGrail 1.0, which I started back in 2015, and which was all about trying to identify the right technology to enter the marketplace. At that moment in time, there were a lot of tracer-based initiatives, and what I brought to the table was the use of digital watermarks. So within the New Plastics Economy from the Ellen MacArthur Foundation, we have been evaluating all of those technologies for 3 years. And the main conclusion was that there is a lot of value in digital watermarks, and that's also the starting point of the establishment of the HolyGrail 2.0 initiative. And so currently we are continuing that work, and we are really focusing on the delivery of HolyGrail into the marketplace. So as already mentioned by Eva, it's an initiative driven by the European Brands Association, and it's now also being powered by the Alliance to End Plastic Waste. This is the latest chart with our members. If I can count still correctly, we are currently having 160 members, so it's still growing. And as you can see, it's a very nice mix of cross-value chain companies. So it's a healthy mix of resin producers are there, converters are there, brand owners, retailers, technology providers, machine vendors, EPR schemes, and many, many more. So it's a very nice representation of all of the different companies that we actually need in these type of cross-value chain collaboration, collaborative programs. If we'll then indeed look into the structure, how we are set up in this initiative, we do have indeed a series of technical work packages, and the initiative itself is being led by a leadership team. The leadership team is basically, again, a representation of the full value chain. You can see here all of the representative on this slide. So we see again 4 brand owners, we see 4 retailers, then we have material recovery facilities covered, we have converters, we have EPR schemes, and then we also do have recyclers sitting in this leadership team. If we go one step up, as already mentioned by Eva, we also do have an advisory group. So here you see the names, Packaging Europe, Ellen McCarter, and the Alliance to End Plastic Waste, where are with us as of from the start. And very recently, we have been adding the AGVU and also WWF. AIM is the initiative facilitator, and we also have a fully dedicated technical project manager, Anne Vossen, which is basically overseeing all of the work which is happening. The fact that we have quite a lot of competing companies sitting in this initiative also requires that we do have a need to have legal counsel into all of these meetings. Partnerships is already something that also was highlighted by Eva. So as mentioned, the Alliance to End Plastic Waste, as well as the City of Copenhagen are our partners in this program, especially for phases 2 and 3. The work packages, which were already highlighted as well. So we have 9 work packages, which you can see here. The first 3, so intelligent sorting, digital watermarks in the print, and digital watermarks in the mold, are really focusing more on the technicalities of the program, where obviously this specific work package 4 is really focusing more on the business development of this program. So again, the objective is really to prove the viability of digital watermark technologies for accurate sorting and the business case at a larger scale, right? So there are basically 2 aspects. The technical aspects, I said, that those are covered in the first 3 work packages, but there is a very important economical aspect as well, which is then fully being studied by this work package 4. Good. So we talked a lot, I would say, about digital watermarks. What is it? Again, you can see here an example of a watermark sample, but I actually also brought one with me. So this is an example of a watermarked sample, where we basically are using existing inks on this print design. And for example, in this case, we would use the existing blue inks in the white area, and vice versa. We are using the white inks into the blue area. Later on, some people will explain it in much more detail, but I just like to keep it simple. So for me, if we do it in the print, it's all about just a kind of a Photoshop manipulation of your artwork file, but we're not changing any ink, and we're also not changing the printing process whatsoever. Okay, so that's one way to do it. And then we are just replicating these type of digital watermarks all over the place. And this is very important because we are working in a kind of a waste environment. So it's important to have as much as possible coverage all over the place, right? Because in a waste environment, these things will be crushed, these things will become dirty. So what we need is actually one readable code. The other way to do it is actually then to start putting the codes directly into the molds. So what you see here on the screen is an example of a mold modification of a PET bottle. So every time we're going to produce these type of bottles, the codes are actually inside that bottle. Here you also see another example of an injection molding trial. And also on this one, we have been putting the codes inside those injection molds. Okay, so those are basically the 2 major technologies to implement digital watermarks into packaging. That makes the package intelligent, and then I can start using that intelligence actually on a sorting line. And what you see here on this animation is a very simplified version of sorting. What we are doing is we are adding what we call an add-on module onto an existing sorting device. So the add-on module is made out of powerful LED light, high-speed cameras, and a lot of computer power, in order to do the analysis of the images. And then we basically can allow product-based sorting, and that really gives you the unique benefits of watermark-based sorting. right? So we're not relying anymore on a classical near-infrared fingerprint, but we really truly can sort now on an SKU, on a product-based level. So it allows us to do things which today are not possible. For example, making distinctions between food and non-food is definitely one of the cases. But as already mentioned as well, we can also have complete new streams, such as detergent grades, cosmetic grades, and others. The project focus obviously is still on intelligent sorting, so that's really the first one. But there is also a pillar which is focusing on consumer engagement, right? So remember the first slide I've shown, there is a need to inform consumers better, potentially also to incentivize to do a better job at home in order to sort their empty packages in the right bins, right? So that's really the third pillar in this program. There is also a very important pillar on data mining, which is being led by GS1, in order then to create a kind of a cloud-based system that the waste manufacturers in the future will have access to, and they can then do a better sorting job. As mentioned, SKU-based sorting is going to be one of the deliverables of this program. Now, digital watermarks also can provide much more benefits across the full life cycle of a package, right? So I touch based on sorting, touch based on consumers, but also for more upstream. So think about the cash register systems at retailers. Also, the digital watermarks enable faster checkouts for the retailers. So that's another benefit. Also for us as brand owners and retailers, also we can use these type of systems for quality assurance in our filling plans, right? So it's important to note it's always the same code, but depending on the reading device, you get type of other information out of it, right? So that really contributes to providing value across the full life cycle of a package. The roadmap, as Eva was mentioning, HolyGrail 2.0 got established last year in September. Then in October, we had a very transparent call for proposals, where we have been inviting all of the technology providers and the machine vendors to actually come up with proposals, which we then evaluated within the leadership team. And as Eva mentioned, we have basically selected two machine vendors, so that's Bellang ST and Tomra, which we will develop then together with the selected technology provider, which in this case is Digimarc. So far, earlier this year, we have been developing the first add-on module with Bellang, which we then validated in September at their headquarters, and that machine then got shipped over here to this facility here in Copenhagen. So we're in the middle of then all of the what we call phase 2 trials, so semi-industrial trials, where we basically are gradually mixing in standard waste, and we are evaluating the performances of the digital watermark samples in almost real life conditions, right? So the further we are getting into that phase 2, the more we are mimicking actually a true waste stream. So work happening here with Bellang, and then more work is going to happen with our second machine vendor, Tomra, and that's going to start around Christmas, early January as well in Germany. So that's basically phase 2. Then phase 3 is the time where actually the brand owners and the retailers will bring commercial product into the markets, and the markets have been selected. It's going to be Denmark, Germany, and France. And then the consumers will buy those products, will use those products, hopefully will put it in the right bins. And then we have selected a couple of sites where we actually gonna test the digital watermarks coming from commercial samples as well. So again, just in a nutshell, so phase 1, it's all about developing the add-on modules to bring us to a specific technical readiness level, in this case of 6. And as mentioned, we are developing 2 machine vendors together with Digimarc. And these were the results that we have established back in September on the first ever add-on module based on the latest specifications. Then phase 2 is basically what we're running here in the center. We do have access to 125,000 package samples, which we are all testing on this machine, and we will provide you with somewhat more details in some of the next sessions as well. But as mentioned, more than 200 different products will be tested. So this is the last session of the virtual events. I think after this session, we have reached, together with all of the previous sessions, we likely have reached something like 550 people in the virtual way, and another 230 people in the real trials we're actually organizing later this afternoon as well. So quite a lot of people now have seen the machine, and we only can hope that is actually going to motivate more people to join and more people to actually put product into the market, because that's really what's going to be needed for this phase 3 delivery, right? So as mentioned, 5 locations have been defined, which is a healthy mix of sorting centers, so the MRF, material recovery facilities, the PERF, plastic recovery facilities. We do have recycling plans there with Borealis and Wellman. And then indeed the MRFs and the PERFs are Suez, Paprik, and the Pre-Zero site in Germany, right? So this is basically what we are planning for early 2022, and this is what we are working against. So in a nutshell, again, this is a very nice quote from Michelle Gibbons. So HolyGrail, it's all about helping to achieve the Green Deal, and we believe that through this innovation, sustainability, and digital elements in HolyGrail, we actually can contribute and make it happen. Good, so with this very small introduction, I would like to give the floor now to Anne Vossen, our technical project manager of the HolyGrail initiative, which will provide you with much more technical details. So Anne, the floor is yours. Thank you.
Thank you, Gian, and thank you and welcome everyone. It is with great pleasure that I'm here to present what we have been doing in the last couple of months here in ARC in the facility to really go into detail and share with you the trajectory of the last weeks. But before we start, I just want to remind you the different phases of testing. We have 3 phases. Phase 1, which is really the build of the machine. And for today, we are focusing on 2 of our technology providers. Of course, Palank ST, who has been building the sorting machine that is currently being installed here in ARC, and we are running at full speed to gain the knowledge needed for digital watermark detection. And of course, on the other hand, Digimarc itself, that is providing the technology for the digital watermark. The reason why we're all here is because we have currently arrived in phase 2 with that development, meaning that we want to check the capabilities of that machine in a very controlled way, meaning that we have full access to the entire line, and what we can do is test for speed, accuracy, and even look at the different elements, how different packaging types are behaving on the actual line. This is very crucial because, as Gian kindly said, is a way forward towards commercial trials, which have been foreseen for next year. But that's jumping the gun. I want to focus on phase 2 here at ARC, supported by the city of Copenhagen, and I have been inundated with a lot of different samples for testing. So let's walk through that and share with you already some key elements and key numbers. This is just a little teaser. This is the machine as it has been installed here proudly on its platform in the test facility at Amager Resource Centre, and we will go live later today to that machine to actually see it in operation. But we cannot run this machine without samples. And therefore, I want to thank the hundreds of members and partners here in this project for sending all of our samples that we have taken great care of, just compacting, making them dirty, which it seems a little bit contradiction in terms, but this is how waste looks. We cannot use pristine packaging. So if we look at the detection itself, based on all the preliminary tests that we have done on all of these packages, we have come up with a result already of a detection rate of above 97% and an ejection rate above 95%. This was really on the validation of the machine even prior to it arriving here in Copenhagen. But coming back to the samples, a couple of the previous speakers already alluded to the 230 plus packaging types that we have received, and the number is still increasing. I think at the moment we are close to 250 total different packages consisting of 8 different categories, and 8 categories, 6 of which are plastics and 2 are non-plastic items. As you can see on the photo, a lot of boxes, a lot of handling, a lot of weight as well. But as I said before, we cannot just do tests on these pristine packages. So what we have done is to really mimic the trajectory that it goes through from the collection into the waste facility. And the first step was compacting. And to do this, we have used a 25-ton press to really make sure it is compressed, it is deformed, and it really resembles the way the consumer would put it in the bin and how it ends up in the sorting facility. In total, this represents 3 tons of materials. It is an enormous waste belt that we have created here for testing, but it's great to see all of these samples coming together, seeing them all side by side, because that is key to the success of this project. What is phase 2 all about? Well, phase 2 is about the testing under very controlled conditions. And this is really using the functionality of the prototype, seeing how far we can take that technology, and therefore we have created 4 different stages. First stage is just to go, what can we obtain? What are the results just without doing anything on base materials? Then gradually we will start mixing in with different materials, different compositions, and really build on our experience for phase 3. And don't forget, phase 3 is commercial sorting facilities, commercial recycling lines, and that's why our machine, but also the software that is driving that machine, has to be ready to turn on and to be operational on long term without any aid and without any control from our side, which we have today in phase 2. And last but not least, we're also going to see how far we can drive this technology by looking at the problem detection mode, very sold material, very compacted. We're going to increase the speed of the belt. We're going to even mix it with residual household waste to really test the options for the future as well, to prove the technical viability of both the technology for sorting as well as the technology for digital watermark embedding into the packaging. What have we already achieved in the 6 weeks that we have been running here in the city of Copenhagen? First of all, I would like to thank everybody here at ARC and the city of Copenhagen for facilitating this, because it has been great working with them and having all their supports. And what we have been doing together is taking this 120,000 plus samples, and we have individually labeled that for traceability reasons, not for detection. And we have done the pre-treatment, both compacting, but also mixing it with real waste to make sure that all the samples are dirty and really resemble waste. Then we have, of course, installed, or at least Palank together with ARC have installed the prototype here. And then all the components have been calibrated. We've also determined the nominal throughput of the sorting here based on a 1.2 meter width of the belt. And that's approximately 2.5 tons per hour. We have run a baseline test of all the samples that we have received just to look at how well they behave. And I can tell you, it is already reflecting the same numbers as we have done in the validation, with a detection above 96% and an ejection above 92% across all the 8 categories of materials. Then the next step, what we did is extracting the marked packaging from the waste stream. Like I said, we used real waste to make our packaging dirty. And what we have done is extract all of that, 3 tons out of 8 tons of unmarked dirty waste. We had our open houses, and also we had 14 what we call VIP events with our full members, and that was attended by 150 people. So that's just a short overview of the last 6 weeks, and we still have quite some weeks to go. But I think for now, I think we have to dig a little bit deeper into the technological advances. And for that, I would like to invite Senior Director Ravi Sharma from Digimarc to explain a little bit more about how the digital watermarks function. Ravi, it's up to you.
Thank you, Anne. It is my pleasure to be here today to provide an update on the progress that we've made on this HolyGrail 2 project. But before I start, I would like to thank the city of Copenhagen and ARC to host this project and provide the opportunity to utilize their nice facility to perform these tests that are going to inform the capabilities and for phase 3 and the capabilities of digital watermarks in general. So it's nice to be able to run these kinds of comprehensive tests in an uninterrupted fashion at this facility. I would like to go back a little bit in time to HolyGrail 1, and Gian talked about this a little bit, but we performed a successful proof of concept demonstration of the use of digital watermarking in the HolyGrail 1 project. This was about 2 years back. And after that, Digimarc really went back to the drawing board to try and understand what would it really take to create a reliable detection of these plastic packaging under the severe conditions that you see in recycling. So we are basically looking at crushed and crumpled and soiled objects moving at high speed on a conveyor belt. How do we reliably detect these and ensure that the watermarks are strong, yet the aesthetics are nice looking? So what we did was we went and created like a reference design specifically aimed at these conditions of recycling. You see a picture on the right there. Those are that's lights, meaning illumination, detection algorithms, the camera optics that we designed to be able to solve this particular problem. In creating this reference design, we were also able to establish a set of specification for a recycling detection module. These specifications include requirements, recommendations, and guidelines on all the components that one would need to build these detection modules, including camera, optics, illumination, the processing power that is used for running the detector, and so on. So in a sense, these specifications provide a blueprint that can be provided to sorting equipment manufacturers to build these detection modules or add-on modules. We also improved and optimized the detector algorithms to be able to extract the watermarks in a reliable fashion. So this is a conceptual view of the operation of the detection module. The Digimarc detection module contains three main components: cameras, illumination, and the processing power required to run the detector. On the illumination side, we made a set of enhancements by introducing additional illuminants compared to where we were 2 years back. And the reason for doing that, for example, one of the illuminants that we added was a blue light, and that was to introduce capabilities to perform the enhancement of the watermark, the enhancement of the printed objects or the plastic objects in such a way that it provides more flexibility to encode these watermark tiles that Gian talked about into the objects. So these subtle variations, so there's a lot more flexibility now to introduce these variations that can be seen well by the machine and yet is hard to see by people. So we have these additional illuminants now. We defined the camera and optics. We identified high fidelity cameras which are able to see subtle variations. So even small changes, we're able to see them better now. The cameras are high speed that allow us to do the operation at 3 meters per second or even higher. The camera frames are then fed into the detector at this high speed. And at that point, the detector is going to perform the detection on each of these frames. Now, this is an area that Digimarc has 25 plus years experience on extracting these kinds of watermarks in harsh conditions or low, what we call as low signal conditions. An operator then dials in the category or categories that they want to sort on. At that point, the Digimarc detector looks for these watermarks and then provides the identifiers and the locations that can be used for doing the sortation. So this information can then be used for further analysis, not just the sortation part, but the further analysis and provide analytics, data mining, and traceability, and so on. So I talked about these specifications. Over the last more than a year, we have been collaborating closely with Pellenc ST, and it's been a pleasure working with them to create what now you see on the right, a picture of an industrial level prototype that Pellenc has created, and it's installed in ARC here in Copenhagen to support the HolyGrail 2 assessments. So for creating this industrial scale prototype, Digimarc provided Pellenc with the set of specifications that I talked about for the detection module. We provided a reference design which had the details of the components, meaning cameras and illumination and so on. We provided them with the software which does the actual detection of the watermarks, and also provided them with the support for the overall software architecture as well as integration. So that has really helped Pellenc accelerate their efforts to create this prototype detection module. And to talk more about their part of the journey, I would like to invite Antoine Bourrelli, Chief Scientific Officer and co-founder of Pellenc ST.
Thank you, Ravi. So it's also my pleasure to address you today, and I would like also to thank our hosts in the city of Copenhagen, and to bring us their very nice facilities, and we'll have a very good cooperative work with Digimarc, with city of Copenhagen, and it's really a pleasure to be here together. So what are our priorities as machine vendors in this project? We are manufacturers of optical sorters, and I will come back to some details of their technology. So the key point, of course, is detection performance on the technical validation, but not only. The machine you will see today is 1.2 meters wide, and we want to be able to implement that technology at full scale. And most of our machines are 2.8 meters wide, and it is important to prove the technology at scale. And another important point is to prove the added value of the combination of these two types of detectors, the spectroscopy detectors with NIR essentially, and the digital watermarks. Once we have done this part, the economic validation is of course of prime importance, and we need the technology to be accepted by the market. So cost effectiveness is going to be the next phase, and we're already looking at it in big detail. Another point is retrofitability, because we want to upgrade existing machines, so not only the latest technology that you will see today, but also some machines of previous generations, maybe not the oldest generations, but at least 1 or 2 generations back. And then the business model is going to be of prime importance, and here we'll think that recyclers are going to be the first target. Why? Because the added information, like for instance food versus non-food or recycled content and so on, that are criteria that are going to be most important for recyclers, and they will have the capability to implement those machines. And then, of course, if we want these products to reach the right recycler, we need the material recovery facilities to provide them. And so some machines in the MRFs will have to be retrofitted to include the digital watermark detection. So to come back for a minute to what optical sorters do, we use NIR spectroscopy to determine materials. So it is based on the fact that each molecule in a plastic or in another organic product, by the way, reacts at a specific wavelength. So you have 3 examples on the screen with PET, PVC, PE, but we have other plastics. So with that, we will detect at which point we have these absorption peaks, and we can tell the difference between most materials on the market. We can also go a bit further. We can tell some different grades. For instance, you see plastic bags that are made of PE, and you see also rigid plastic bottles that are also made of PE, but we see clear differences between these two. We can also see some additives. The milk bottle in the middle has a carbon black layer inside, and it shows with a different false color on the screen, so which means we have some capability to go below the surface. We can do the same kind of things with the vision in color, but I won't go into the details here. And what can we not do now with this NIR technology? First of all, there are things we can do, but are much more difficult to do, like, for instance, in PET, making the difference between PET bottles and PET trays. They are made of the same material. The only difference is the manufacturing process. Some are thermoforms, other ones are injection molded. And so there are very slight differences that we can see in spectroscopy that are consequences of these processes. And you can also imagine to look at shape, and you can see pictures on the right. The bottles are actually the 2 objects on the top, and the trays are the 2 objects on the bottom. So looking at shape might not be that easy. And so, of course, if you write into the object, whether it's a tray or a bottle, you solve the problem. We can also look at sleeves on PET bottles that completely cover the bottle. Usually we can tell what is the material under the sleeve, but we can hardly tell whether it is a clear bottle or a colored bottle. Then multi-layers, we can go to the 2nd layer, but maybe not to the 3rd layer, and you can imagine many complicated designs here where we will have trouble. And then it's also true for additives. And if we go further, we have criteria that are completely impossible to tell with our design. That is food versus non-food. A shampoo bottle that's made of PE and a milk bottle that's also made of PE. We cannot tell there was shampoo or milk inside. So we need that information from another source. Black products based on carbon black. It's also not possible. Carbon black absorbs all the NIR signals, so we have no answer at all. So we completely rely on the digital watermark information in that case. If we have to see behind a metallized layer, even a thin one, it's impossible. So same conclusion, we need something else. And then recycled content is going to be a key issue in the years to come, because it's going to be a basis for regulations at European level for recycling. So if you can write this recycled content into the product, it will help greatly. Same thing applies to bio-based content. In case you have a mix of bio-based and petrol-based plastics, if you write it into the product, it will help. And last but not least, traceability, as has been mentioned already, is essential. You will be able to tell during the whole life cycle of the product what has gone through the MRFs and to the recycling center. So about how the phases, it has already been explained, so I will be a bit quicker. In January 2021, we concluded the initial phase. We had started actually with Digimarc alone, and that one had the aim to sort at least 95 or 98% of 4 different product references, and we were very pleased to see that we had actually a 100% detection rate. So we were very enthusiastic about going further, and we built the prototype that you will see today, and it was completed in September. And as you know, we are in this semi-industrial phase now. with all the details already explained. Ongoing is the combination with the near signals and the problem detection modes. So that there's still work on the table. And phase 3 with the different industrial sites will come in next year. So we want to show you what the machine looked like in early September back in France. And you could also see the main features. So we have a small video in 2 parts. So if you can send the first part, where we will see that we will eject all products. Should I push the button? No, sorry. Okay, so you can see the main components, sorting belt on the left. The detection units are all behind the blue casings. Then the digital watermarks module, that's computer system. This is random feeding, so no cheating. So this is really the way the products will land in a true configuration. And in this first phase, what we want to do is eject all the marked products. So we tried with different sets. And you can see that most of them are ejected, and the ones that are not will fall in the gray boxes that you see now from the top. So you see very little products in these bins, and most of the products land on the other side. After that, we will show a true sorting, which is separating different types of products. So we have chosen in this case HDPE and PP as the target fraction. And you can see that these products are all ejected, and you don't see almost any of them falling in the gray boxes. And other products like Tetra Paks, for instance, are not ejected in this case. So that was it on September 9th. And so with that, that was not the end of it. We had to carry the machine. So just 1 week after that, you can see the machine arriving in 3 pieces here in Copenhagen on the September 20th in the morning. And in the evening of the same day, it was already installed in the facility. And 1 week after that, we completed the connections with the arc line with the feeding conveyor from the side. And we had the set ready for sorting. This is what you're going to see next. And just a quick look at the inside of the machine, which you will not have a chance to see. If I look at the picture from the right-hand side, you have, first of all, the spectrometer with the white light that will tell us material and color. Next to it, you have the digital watermark cameras with the violet-looking light. Actually, it's a combination of blue, red, and infrared. And these two are as close as possible to the end of the conveyor so that we are not influenced by possible movements of the objects on the belt. Then we have the computer system dedicated to the digital watermark processing. So a pretty big set of computers. And last but not least, the turbo sorter, which is the device we use for light objects to stabilize them on the belt. So it gets air from the outside and creates a laminar flow of air that goes at the same speed as the products on the belt, so that light objects like paper sheets or flexible plastics will not slide when they are detected, and so they are correctly ejected. And so I think you will have a chance to see that in more detail soon. So with that, I would like to give the floor back to Ravi for some explanations on the samples that have been prepared for you. Ravi, the floor is yours.
Thank you, Antoine. So let's talk a little bit more in detail about the large assortment of products and the massive amount of samples that we have here in Copenhagen, contributed by the members and partners. So we have a large variety of 2D, 3D, and combined. And this includes a variety of artwork, all kinds of substrates, all sorts of resins, shapes, sizes, form factors. All of the key manufacturing processes and printing processes are really covered in this product, in these products. And really the emphasis is on sorting the use cases that Antoine talked about, which NIR finds difficult or impossible to sort. So those are really the focus areas that we are looking at. And these numerous products, and you see a sampling of the products on the two tables. I think this is a view of the display room here in Copenhagen. And these products have been enabled by not only Digimarc, but 30 of the key industry suppliers and partners, and this number is growing, that have provided capabilities ranging from prepress, printing, converters for the 2D side, and on the 3D side, plastic packaging manufacturers, converters, engravers that we have used to engrave and emboss the watermark in 3D. So let me now talk a bit about the advancements that Digimarc has made over the last several months, both in 2D and 3D. And this, again, going back to what I was mentioning in terms of the specifications that we have established. The specifications have really allowed us to address large white areas, large black areas on the print side of the watermarks, transparent areas, Pantone colors, metallic substrates. So really, the capabilities in the detection module, including the illuminants, the cameras, the fidelity of the cameras, the high dynamic range of the cameras, the high-speed cameras, have allowed us to be able to address the aesthetics and strength trade-offs that are required for the reliable detection in the recycling conditions. On the 3D side, we have proven now the feasibility of the 3D watermarks across all kinds of materials, manufacturing processes, and again, form factors. So including PET, rPET, PP, HDPE, and multi-layer objects. And we have covered the key manufacturing processes, including stretch blow molding, extrusion blow molding, thermoforming, injection molding. So what you really, where we are right now capabilities-wise, that it can be done. Phase 2, the objects are here. We are evaluating them. We are ready for phase 3. There's a sampling of the objects that you see on the right, addressing some of the areas that I talked about, including whites, blacks, the various substrates and resins on the plastic side. So let me show you a video of the display room here in Copenhagen that's showcasing these products. And the video doesn't really do justice to the quality, to the aesthetics of the samples. You really have to be here in person to be able to understand the capabilities. Even if you have worked with us in the past, I think this is really, you can really see the significant improvements that have been made in getting the watermarks into these products. So let's then talk about where we are in terms of the testing. So as Anne mentioned, we are in phase 2. The testing is in progress. The initial results on the baselines, just to reiterate what Anne was saying, we see very promising results so far on the baselines. The detection is healthy, the ejection is healthy across all categories. We're not just looking only at the detection and ejection numbers, we're also analyzing the results in far more detail to inform the capabilities that are required for phase 3. So as the detection module is working, we're making captures of everything that the cameras observe, the detection cameras observe. We are also taking captures of various parts of the belt as the tests are performed. And then all of this information is shipped to the cloud, where we can perform analysis on what is happening and understand the behavior of the detection under various conditions. For example, by the type and characteristics of the object, by the conditions, how much soiling, by the enhancement applied, and we can also perform various types of detections in the cloud. So just to give you an example is a picture on the right, which is looking through a camera, cross-section of the belt, and looking at these objects. And you can see these detection markers, which shows how many detections. Let me show you a zoomed-in view here all these markers that you can see on the objects is the number of detections that we can see from this object, even though it's in a crumpled and crushed form. So this is really where some of the innovation that has gone in terms of identifying the right illuminants, the right set of camera and optics is helping provide this significantly nice results that we are seeing so far. So with that, I would like to hand it back to Anne Vossen to take you further.
Thank you, Javi, but also Antoine, to go through the technical details and the background, explaining how you came from having a set of standards and a set of specifications to an actual working machine. So really what we want to do during this tour, and since you have a virtual tour, we cannot showcase everything. What we just wanted to give you is a short introduction and an impression of everything that has been going on here in the last couple of weeks. And that's why we have made a video just compiling everything that happened in the pre-treatment before actually going live to the sorting machine itself. So, Steen, if you can just show that video, that would be great. Yeah, and as you can see, there was a lot of logistical work that came into the actual preparation of the samples to be ready for today's event as well. Of course, we cannot showcase all of the materials, hence we had a poll earlier today. And let's look at the results. Oh, actually, yeah, there they are. That it's clear that we have 150 people actually did a vote, and the winner of the one that you are most interested in are the flexible plastics. And that's why we have our team ready with the flexible plastics that we will showcase you today live from the machine. And to help me with that, I invite Tomas Fuller, Senior Manager R&D from Digimarc, to join me here on the floor.
Hello, everyone. It's my great pleasure to be here and walk you through the live demonstration of what the sorting will be. We have 2 tests prepared, and the first test is actually ready to go. So in order to run live, I'm just pressing the go button and asking the team to actually run the first test. So before we virtually transfer you to the testing site, what I'm showing here on my screen is a photo of 4 items that we will be ejecting. Those were selected out of a set of other flexible items that do contain digital watermarks. And let's actually move virtually to the testing site. So here what you see is a live view of a system that has been explained and shown in images before, where, and as you can have seen in the previous video, the items are going to be fed through the system of conveyor belts. And now I can walk you through the whole setup. This is the first conveyor belt where we are feeding the flexibles into the machine, and it may take about a minute before all the flexible items are going to reach the final machine. But this is the belt which we used to originally count and validate the results by manually counting each baseline result that Anne presented before.
Yep, and it's looking great, but if it takes a minute, can you maybe explain the other cameras and what you can actually see on that?
Definitely. So we have, this is the master view of all the cameras that we have available. So on the far left here, the first camera is actually the camera taking all the images of as the items are coming onto the belt. So we can see that the flexible items are already coming on the belt. The items are going through the machine, and you can see the colored illumination that was described previously. And then we can move to the final ejection. And here you can see how live the items are being ejected. And only those items that you have seen in the previous image, only those are being ejected. So here you can see as the items are coming on the belt, and ejections are happening from the middle bar through the individual air jets based on the detection of digital watermarks.
I know we are live here to the machine, but can we actually see what has come out of there?
So we are still in the process of running the experiment. So we can see the output bins where on the left items are falling down by gravity, as explained before. And on the right, items are being ejected over the middle bar. So the right side here are the ejected items. On the left are the remaining items. So here, soon we will finish this experiment as all the items are going to go through. And it looks like we still have few items coming in.
So in the meantime, since there's still some samples coming in, can we maybe explain a little bit more on the right hand, what we're actually seeing there? The video on the right, what is the detection? What kind of detection are we now using?
So here on the right, the detection is happening based on items going on the belt, and you can see 2 sets of lights. One is the colored on the top. You can see the purple-blue illumination, and that is coming from the digital watermark detection module. And then you have the white strong line, which is coming from the near infrared. So in the existing demonstrations, all the ejections are happening based on a digital watermark only, and currently near infrared is not being used. As explained by Antoine before, the systems can be combined to provide further improvements in detection and ejection rates in cases where NIR is meaningful to use.
But that's definitely in the program later on to that combination. Is that happening soon? Or do we need still to wait a couple of weeks before that? When can we see that actual results and see if there's an actual improvement by using infrared?
Yeah, definitely the combination is essentially based on do we see digital watermark? Is that item, should that item be ejected? And let's say if we are ejecting food safe versus non-food safe in these kind of applications, digital watermark provides the means of identification in terms of this item should be ejected. And then potentially near infrared could provide the region or the area where the whole object is to provide a safe ejection of the complete item. So we are currently sort of in the process of working on the implementation and testing. So, but the result so far seems to be promising.
That's great to know, Tomasz. And it seems that we're nearly done with the materials. So as many of you, we are very curious to see what is actually in the bins. I hope that's also an option. And I know that you have something else that you want to showcase as well.
So I have 2 more updates coming after this. There will be an image. You can already see the full bin of ejected material, but I will provide a more detailed image of that. Now, the team is actually pulling the second blue bin, which contains the non-ejected items. And we should get a photo of both of these, just to be able to see that whether how many items we actually ejected. And then in the second, after maybe a minute, we will have a live update on how many items have we actually detected in this mixed stream. So we have put about 100 items of each SKU in. So we will see based on the numbers, we will see how many we were able to detect. So let's see if we get updated images here. So far not.
But you were telling something about numbers. So you said 100 each. Does that mean that you're actually counting them as well?
That is correct. We have the capability to, and actually let me demonstrate on a, and this all is running live, so we have not pre-recorded anything, but let me demonstrate this on a single item so far, and then we will show the more complex case. You can see that it's a similar image that has been shown by Ravi before, where a single item coming on a belt, you see so many of these individual green dots being collected together. Those are coming from the watermark detection module live, running at 3 meters per second. So all these green points are essentially combined together, and we see that, oh, this was most likely a single object.
That's very interesting to see, and there's many dots of that. So that's also why you're insisting on high coverage, I guess?
And high coverage is definitely something that makes sense from a perspective of crumpling, crushing. Really, the environment in waste sorting isn't favorable, isn't ideal. Every time either crushing, crumpling happens or folding, items might be coming not nicely flat. Items might be just crumpled in a ball and coming at coming like that on the sorting belt. So here comes the live images of the output. What we would want to see is, here are the set of 4 items that we were supposed to eject. Now if
So it looks like the top is indeed these products that you mentioned.
Exactly. Those are the flexible items that maybe they don't look like the nicely folded items that I showed before, but they're crumpled and sort of they look slightly different. So these are all the items that were ejected, the hygiene flexible products. And then this is the rest. These products were not ejected, so they fell by gravity into the second bin.
Okay, I can see one at least that it's missed. I see that one blue packaging, but for the rest, it seems a very good quality indeed. Can you show with numbers maybe what we have achieved?
Let's look at the numbers. Let's see if, oh, they are actually in. So here we are looking at the detection for line items that have been pre-programmed into the machine to be ejected. And then out of 100, most of them were out of 100 except the second line, the always we only put 50 items in. So in this case, we have 90 counted items, but sometimes when two items come really close together, it might be difficult to distinguish that they are different because they are of the same product type. And let's look at maybe how some of these items really looked like when they were coming on the belt. So here you can see that this was perceived by the algorithms as one item, but they are really two items overlapping on top of each other. The same product was going on the belt. So this is definitely sort of undercounting the result of 90 detections that were provided.
Okay,
And there are others like that.
Okay, so that means that the actual numbers that you just shown are are higher than the ones that are put on the screen?
That is correct. So the number 90 here is just the number of so-called clusters that we have seen on the line, and some of the clusters may contain more than one item.
And Tomasz, we have seen on the left the names of all the products that were in. So what would happen now if we would randomly select different items? Is that something that is achievable, or do we have to always look at specific categories? Can you tell me a little bit more on that?
That is exactly the reason why digital watermarks provide the flexibility, because each product with a unique may have a unique watermark. What that means is there's a different number essentially encoded in each of the product. So one flexible item might have a different number than some other flexible item. And what that allows us to do is to essentially do a SKU specific sorting. We can select that only the first line item should be selected and nothing else. This can be either based on SKU specific or based on some other categories that are related to the SKU specific. For example, the material, food, non-food, potentially others. So there's unlimited amount of properties that could be attributed to a single code that can be later used for sorting.
That's very interesting. So that means that we can maybe go back to the machine and have that actually shown to the audience, because I mean, seeing is believing. So is that something you can demonstrate next?
So it looks like the next items which we were thinking of running were actually these four that you can see on the screen. So we have selected two black items. One with, on the left, is a 3D tray with thermoform tray, and then paper-based product and a PET bottle with a full shrink sleeve. So.
Okay, so if I go back to Antoine's presentation, he was saying carbon black, infrared, it's not a good match. Sleeve, we have some difficulties if it's completely covering. So you're saying you can actually solve some of the issues that standard infrared has.
And exactly, the second item here, the paper-based, has a metallic layer inside, which might sort of cause difficulties in the existing sorting systems, not even speaking about the carbon black.
Okay, let's maybe go to the live to the machine again and see how this performs on the line.
So I think we have already ran these items. So maybe let me check the results and let me check the updates on. So that is exactly correct. We were supposed to eject the black trays here, the PET full shrink sleeve bottle, and here you can see the Nivea black container, as well as the paper-based carton with the metallic layer. So this is the result of the ejected bin. It is looking like most of these items in there are actually the ones that we have selected. And here is the remaining.
there's a clear difference. I don't see any black there, and it's highly black on top. So well done. And I guess if you have run it previously, there's also some numbers to demonstrate how well it performs.
Let's look at the system if we can get. So we have actually the live results coming out. So these will be out of 100. So we have created a blue bin consisting out of 4 items. Each we had 100 individual packages of each item in there. So these are the numbers, 94, 95, 95. These are out of 100. And again, some of these might be coming close together in the clusters so that we might, actually these numbers might be slightly lower than what they actually were.
Yeah, so I see indeed that you have some remarks next. Oh, there's even 3 there.
There are even 3 that were detected.
So that's a lot higher number than the actual number that we initially saw.
And you can see how the black trays are essentially covered with the green dots, meaning there's many detections that were happening as the trays were coming on the belt. And we only need 1, really, to perform the ejection to be able to identify the location of the item.
Okay, that's very great to see. Thank you so much, Tomasz, for your assistance here and going live to the machine. Well, unfortunately, since it's a virtual event, we don't have much more time to run other materials. And therefore, I know most of you probably have some more questions. So therefore, I want to hand over back to Eva for a Q&A session. Eva, please.
Thank you, Anne, and thank you all for the demonstration. Yes, so we have received quite a lot of questions from the audience, the participants, and we have done a selection of the ones that you really stood out. So let's start. I will invite the experts to join me here to give you their perspective. So the first question, what are, and this is a question that we often receive, what are the major hurdles from here to be worked out before full implementation of the technology? On that note, I would like to ask Gian to join me. Gian.
Yes, thank you very much, Eva, for the question. So indeed, this is a question we get often within the initiative. So let me again remind the people, the objective of this initiative is to prove the viability, both technically and commercially as well. So I think from a technical point of view, I hope that you are convinced that the system is well performing. And this is also the message we are getting from the other technology providers. So from a technical point of view, we're very convinced that it's actually gonna work, right? So there is always this question on business models, right? And this is basically being tackled by that specific work package number 4. So this is gonna be a very important one. It's the kind of, the classical chicken and the egg, right? So there is a need to invest across the full value chain, right? So the waste manufacturers actually need to invest in these type of add-on modules that they can install on their existing sorting equipment, whereas the brand owners and the retailers, they actually need to do small investments and create a bit more complexity in the systems by modifying their packages, either in the artwork or again, through the molds, right? So that makes it somewhat complex, but again, given the fact that several players need to do something, we believe that by setting up such a cross-value chain collaboration program, it's all about the shared responsibility, and again, we have to solve it as a true value chain on this one, right? So again, if we're looking to all of the ambitions that we also have been showcasing earlier, there is definitely a need to do something, right? So we cannot just wait and see. Those recycling numbers won't go up naturally, right? So we need to come up with solutions, and we believe that programs such as HolyGrail 2.0 actually can contribute. We have been talking about dividing streams, food, non-food, detergent streams, so forth. We have been talking about coming up with real numbers, real recycling numbers, real data on recycling numbers, which is also unique, I think, to this program. Full data granularity we have been touching, passports we have been touching, but What truly is needed to speed up the implementation, and that's also being discussed as we speak, is that we look into kind of incentives, right? So incentives provided by authorities, incentive provided by EPR schemes. So think about, you know, a bonus system on the EPR fees for the early adopters. We believe that by looking in such incentives, we can convince more brand owners and retailers to join us in this journey, right? So I've mentioned we have indeed 160 members. Quite a lot of brand owners and retailers are already there, but we definitely need more to make it work, right? So again, these are a couple of hurdles. I hope to have answered the question, Eva. So thank you.
Right. Thanks, Jan. So for the next question, which is referring to recyclers and material recovery facilities, Antoine, please join me. So the question that refers to these stakeholders, and that is really of a big interest among the audience. How will recyclers and MRFs need to retrofit their existing facilities to incorporate the watermarking technology and additional sorting lines?
Thank you, Eva. So this raises a couple of different questions. First of all, the digital watermark detection system is a detection tunnel that can be added in front of an optical sorter, as you have already seen in my presentation. So that is usually easy when you have that space available. So at recycler site, I'm rather confident. At MRFs, maybe a little bit less. But also the other issue is that you have to create a new outlet. And this is again maybe a bit more difficult in existing MRFs because the architecture is usually very crumpled. There are a lot of equipments already on site, and it is not always possible. So this is something that will have to be looked at. And well, of course, the economics of the systems are also important. It has to be affordable, but we're working on that, and we're confident that we can make it affordable.
Great, thanks, Antoine. One question that is also of interest to a lot of people is, what is about non-plastic packaging? So is there a possibility to actually achieve also higher recycling rates by embedding the digital watermarks on non-plastic packaging? And for that, I would like to introduce Anne. Anne, join me.
And it's a very good question indeed, because initially when we started this project, we were focusing on plastic packaging, but very soon we already got that question, what about other materials? So we opened up the scope of our project to incorporate already fiber-based packaging, liquid cardboard, but also very complex fiber-based packages. And as you have seen in the poll already, we have samples of those materials included. And yes, there are capabilities, and we are able to introduce digital watermarks in these types of materials as well. And we're running tests to compare to see what are the possibilities there. And if that's possible, indeed, there are some challenges for those sectors as well. And they can use, similar to plastics, that technology to separate their plastics in higher quality, and therefore also going into higher quality recycling as such. I hope that answers your question, Eva.
Okay, so yeah, the next one refers to flexible packaging. We have received a lot of questions on this packaging material. And yeah, I mean, you could see it already in the live demonstration that flexible packaging items are actually sorted. But I would like to invite Antoine to give a little bit more background on how these flexible packaging is actually sorted, especially, especially if it's scrunched or wrinkled.
Okay, well, I guess by the choice that the public has made, you have already part of the answer, but we thought it might be worth showing you it in more detail. I was explaining before what the turbo sorter was, creating that stabilizing flow of air and bringing all the products at the same speed as the belt. So we have prepared previously a small video with another set of flexible packaging being sorted. So you can see them sorted now with the turbo sorter. And you will see this product on the right. So you have to remember the categories here. And so we have run these products. And then we have made another video here with the same products without the trouble sorter. So this one should have been ejected, for instance. And you can see a much less reliable operation in that case. And we have actually counted what was happening in this test in particular. And we counted 70% ejection rate without the trouble sorter, what you're seeing right now, whereas we counted more than 95% ejection rate with the trouble sorter. So that's part of the explanation. And of course, other challenges on flexibles are, can we detect multi-layers and so on? But this is also something that where we have very good results.
Great, thanks for this more detailed background. Next question refers to the digital watermarks. Ravi, please join me. So the question that we received, is there a risk that the Digimarc codes will be detected by the barcode reader at the cashier of the retailer?
Yeah, that's a good question. At the barcode scanner, the digital watermark actually can supplement the presence of the barcode itself, and so that can help detection of the object or recognition of the object faster. Once you have these watermarks which are all over the object, then you can really accelerate the checkout or do a faster checkout. In fact, Digimarc detection is already integrated in the major manufacturers of barcode scanners. So this can really provide that faster checkout capability. So it's all additive and helps the process. I would say that once the digital watermarks are in there, not only helps the barcode scanning, but as Gian mentioned, it's throughout the life cycle of the package. It can support a whole set of applications, including manufacturing, consumer engagement, all the way up to recycling, as we are discussing. In a way, the digital watermark provides you with a digital product passport, like an identity that goes on with the object, and that can serve as a platform for enabling all of these applications.
Great, thanks, Ravi. Next question, and this also comes a little bit into play with the first question, for the implementation. What is the business case for the system? I can take the question already, and it has been already mentioned before that, of course, we're not only looking into technical viability of the digital watermarks technology, but also into the economic viability and the business cases. For that, we have a specific work package, which also was mentioned by some of the experts, on the business development. And for example, we are looking into a business case evaluation study that is conducted within this business, within this work package. This information is, of course, shared internally. It's work in progress, but we will publish the results at the end of the project together with our techno-economic analysis, and we just need a little bit more patience to finalize everything. Good. On that note, the last questions. We see a lot of projects, of course, also in the circular economy debate, also referring to recycling and sorting. And I would like to ask Gian and Antoine to join me for the last question. Are there other international projects trying to solve the same issues? And if so, have you identified any conflict?
Thank you very much again for the question. So indeed, quality recycling is for sure the buzzword these days. Quality recycling obviously starts with good quality sorting. So yes, we do see quite a lot of activities. In fact, already back in 2015, we have been doing that analysis under the original HolyGrail 1.0 program, right? So again, together with our first 39 partners, which you can see here on that slide, we eventually have been looking into all of the activities, specifically in the field of chemical tracers. And as I was mentioning in the beginning, what I brought to the table was the use of digital watermarks, which, again, back in 2015 was completely new. So we are indeed evaluating all of the different systems, including tracers, also as part of the work package on business models, right? So we are keeping track of all of these items, but I just wanted to quickly showcase also the main conclusion out of that pioneer program from the Ellen MacArthur Foundation. So here you see the comparison between watermarks on the left-hand side and tracer kind of systems on the right-hand side. But I think it's very clear that in terms of the watermarks, we have infinite granularity, but also the ability for the consumers to read items through their mobile phones, which obviously is not the case with a chemical tracer, as an example. Okay. Now, obviously, the technology is evolving. So as I said, we are following up all of the tracer programs, but on top, we are also having a look into complete new technologies such as artificial intelligence. We don't see AI as being competing with HolyGrail. It's actually, we see it more as complementary in the spirit of like 1 + 1 = 3. So obviously, AI is based on probability, whereas watermarks is more like deterministic, right? And so we see really huge advantages of combining eventually the AI then combined with the watermarks. Now again, I also would like to give the floor to Antoine to provide some further perspective on that field.
Thank you, Jan. So actually, as you said, AI is also a hot topic with us. We are following actually both tracks with parallel projects at this very time. And first of all, I'd like to mention some basic differences between the two technologies. So as Jan mentioned, AI is probabilistic, whereas digital watermark is deterministic. That means that you always have a chance to make a mistake on a given object with AI. But on the average, the proofs of concepts are very encouraging, and we get to the same level of efficiency from what we can see at this time. But the differences are very much first in the hardware. The hardware you need for AI is actually, I would say, standard vision cameras, not very high resolutions, not very sophisticated lighting systems either. So the hardware itself is, I would not say cheap, but it's very affordable. Whereas for digital watermarks, it's a hardware-intensive system from the beginning, including lighting and processing power. So the investment in the hardware is different to get started. But then what happens in the software is that the digital watermark is finished when you start, and you have no chance of making an error, whereas on AI, you always have a chance to see a new object appearing on the market, and so you need to constantly update your database of existing products to keep track of that and to avoid sorting errors that might occur after the implementation of your system in industry. So these are different types of constraints that have to be taken together, and you can imagine more cooperation between the two technologies in the future, and this is something we will be investigating starting next year, as we are investigating right now the benefits of combining NIR spectroscopy with digital watermarks. So the challenges of recycling are so high that we don't think we should avoid any possible technology.
Thank you, Gian and Antoine. On that note, we have reached the end of our second virtual open house here in Copenhagen. Thank you all for joining us. Thank you to the experts that have made this happen. If you have any comments or suggestions, please do not hesitate to directly reach out to us. Have a nice day. Bye.